Dear students, we have already started with electrochemistry chapter. In the last class, we discussed about commercial cells and batteries. And today I'm going to introduce a topic. Children, you might have seen some articles like this is a silver katori. It is very shining white, but if you see from the back side, when it is exposed to air and moisture, then you will see it turns to black. So even in my mandir, I have some deities which are kept. They are made up of silver and they turns black. Similarly, there are certain other articles in the house. Maybe this is a jug which is made up of an alloy of copper. It also turns blue when it is not in use. Somehow we are using it, so it is looking like copper, but otherwise it turns to blue. Children, you wear sometimes some bangles or maybe some rings which are made up of copper. So your ring also turns blue because of that. So that is all because of a phenomena called corrosion. So today I am going to introduce corrosion. How will you define corrosion? Beta, corrosion is a very slow process. It doesn't take place in few minutes or few hours. It takes a long time. So it is, I'll say, it is slow conversion of a metal into their undesirable compounds These undesirable compounds could be oxides, carbonates, or sulfates. And when does this happen? When it is exposed to air and moisture. You might have seen, especially in case of iron, that a brown layer or brown flakes develops on it when iron is exposed to air and moisture. So when iron undergoes corrosion, there is a special name given to it. It is called as rusting. Rusting is very harmful in the sense because it eats away the metal. Continuously, iron is exposed to air and moisture. Brown flakes are formed, brown rust is formed, which falls off. It is not very stable. It doesn't stick to the compound. It falls off. And as soon as it falls off, again metal is exposed to air and moisture. Again rust is formed, and sometimes holes are formed in the iron article. So it is a harmful process. It affects the economy of a country also because it needs lot of maintenance charges to prevent iron from rusting. But sometimes it is advantageous also. Like you might have seen in front of the shops in the market that there are some aluminium sheets. They are very shiny and they never turns black or into some other color. It happens because aluminium also undergoes corrosion and turns into aluminium oxide. But that aluminium oxide is very stable. It sticks to the aluminium and that is as silvery white as aluminium is. So it prevents the aluminium from further corrosion, and aluminium oxide is a protective layer which is formed over aluminium and it prevents the further corrosion of aluminium. So in this way it is advantageous process also. Children, there are some factors which affect corrosion. So let's discuss factors affecting corrosion. One of them is reactivity of metal. You know, the metals which are very reactive, they undergo corrosion to more extent. It may be iron, copper, zinc, metals with low reduction potential are very reactive and they undergo corrosion easily. You may check the electrochemical series. At the bottom there are more number of metals which have more tendency to undergo corrosion. So they have low reduction potential, so they are reactive and more tendency to undergo corrosion. Another factor is presence of impurities. Where? In the metal. Do you know, if an article is made up of pure iron, it will not undergo corrosion. But generally, most of the articles of iron are made up of impure iron, pig iron or wrought iron, which contains impurities. In such cases, corrosion will be faster. It enhances the rate of corrosion. So presence of impurities increases the rate of corrosion. Presence of electrolyte also enhances. Generally, water is not a good electrolyte. It doesn't ionize to give hydrogen ions which are required for corrosion to undergo. That you will understand in the mechanism of corrosion. But if suppose some pollutants are present in the atmosphere like carbon dioxide, sulfur dioxide, nitrogen dioxide, etc. So they will join with water and more hydrogen ions will be available for rusting to carry out, and in such cases rate of corrosion will be faster. Children, today we are going to study about mechanism of rusting. Do you know what is the formula of rust? You have already studied in junior classes. It is hydrated ferric oxide. Ferric oxide is Fe2O3.XH2O. Some water molecules are associated with this. There were many theories which came forward, but out of all the theory, the most accepted theory is electrochemical theory of rusting. You might be wondering why we are studying corrosion in electrochemistry. Because the mechanism of rusting or corrosion is based on electrochemistry. Here in this case, an electrochemical cell is set up. See, how does it happen? Suppose there is an iron article. Generally they are made up of impure iron. So at one place where iron is present, pure iron, it acts as anode. And at the nearby place where impurities are present, will act as cathode. And who is the electrolyte? There is moisture in the atmosphere as well as on the surface. Some oxygen is also there. So that moisture, oxygen will act as electrolyte. If carbon dioxide is present, that will also enhance the rate of corrosion. So in order to set up an electrochemical cell, we need anode, cathode and electrolyte. And electrolyte in this case is water along with other impurities which are there in the atmosphere. So see, what are the reactions which are occurring at anode and cathode. At anode, iron get oxidized to ferrous ions and it loses 2 electron. You already know oxidation occurs at anode, OA, oxidation at anode. Loss of electron is oxidation. Otherwise also I have told you, here the oxidation number is 0, here it is +2. So electrons are written on the side where the oxidation number is more. So oxidation occurs at anode, that is at pure iron. These ferrous ions, they move into the solution now, and electrons, they start moving from anode to cathode through this electrolyte, which is water or moisture, or maybe some water droplets are there. Then I would like to write down the reaction which is occurring at cathode. At cathode we need hydrogen ions. So before that we need source of hydrogen. So first step is reaction at anode, second is source of hydrogen, and then I will write down reaction at cathode. You know, water also ionizes, although it is a poor electrolyte. To some extent it might ionize, it gives hydrogen ion, but generally water joins with the gases which are present in the atmosphere, maybe carbon dioxide, sulfur dioxide, so it changes to carbonic acid. Carbonic acid, though it is a weak electrolyte, it is a weak acid, still it ionizes to give you hydrogen ion and carbonate ion. So hydrogen ion which are obtained by ionization of water and by carbonic acid will move towards cathode and see what reaction happens at cathode. These hydrogen ions which are obtained from the source will react with oxygen which is dissolved in the moisture. You know, some moisture is there on the surface as well as in the atmosphere. These the oxygen which is dissolved in moisture will react with this and it changes to water. Here if you see, hydrogen is +1 here as well as it is +1 on the product side also. But if you check the oxidation number of oxygen, here it is in the elemental state, it is 0, and on the product side it is -2. So there is 2 electron change. Although there are 2 oxygen, but I'll write down half here, so this becomes 1 oxygen here and in the reactant side also. So there is 2 electron change, and at cathode reduction occurs. Reduction means gain of electron. So I'll write down 2 electron on the reactant side. When I say gain of electron, it means we'll write down on the reactant side, and loss of electron will write down on the product side. Otherwise also here the oxidation number is 0 and on the product side it is -2, and we write down the electrons on the higher oxidation side. 0 is higher than -2 oxidation number, so we'll write down the electrons on the reactant side. Now in both the cases you check the number of electron change. Here it is 2 electron, here also 2 electron, it is equal, so when I add up the 2 reaction there won't be any electron. So fourth step is overall reaction. Add the 2, you will get here iron plus half O2 plus H plus. Electrons will be cancelled, and finally we get here Fe2 plus H2O. This is my overall reaction. Still iron is in the +2 oxidation state. We call it as ferrous ions. Now these ferrous ions in the next step, that is 5th, will react with atmospheric oxygen. Previously they have reacted with oxygen dissolved in the moisture, but now it reacts with the atmospheric oxygen, and also it reacts with moisture which is present here, and it changes to Fe2O3 plus H plus. If I balance this, I may write down here half, and this is 2H2O and this is 4H plus. Now ferrous ions have been converted into ferric ions. So it is Fe3 plus. +3 is the oxidation number here. And in the last step, this ferric oxide reacts with some water molecules. There is no fixed number of water molecules are there. So it forms Fe2O3 dot XH2O, which is the formula of rust. So rusting occurs on iron in this manner. This is the most accepted theory of rusting of iron. So let me repeat quickly. Pure iron will act as anode. Impurities will act as cathode, and electrolyte is present here in between the two, where some water droplet, moisture, oxygen and other gases are playing the role of electrolyte. At anode, oxidation will happen. Iron will change into ferrous ions and 2 electrons will be evolved out. Electrons will move toward the cathode. Ferrous ions will move into the solution which is present between anode and cathode. For the reaction at cathode, we need hydrogen ion, but before that we need to know what is the source of hydrogen. Hydrogen is obtained by the ionization of water, although the degree of ionization is very poor. So water joins with the pollutants present in the air, maybe carbon dioxide, it makes carbonic acid, hydrogen ions are now available. These hydrogen ions will react with the oxygen which is dissolved in moisture, and it will undergo reduction to form water. This is the overall reaction, and ferrous ions present in the overall reaction will react with the atmospheric oxygen and it forms ferric oxide. Ferric oxide becomes hydrated by reacting with the moisture present in the atmosphere, and rust formation takes place. Children, all through this process you might have understood, in order to carry out the process of rusting we need hydrogen ion. So if hydrogen ions are not available, rusting will not take place. So shall I say, this is a noteworthy point, that in basic medium rusting doesn't occur. So this is also one of the phenomena where we can say we can prevent rusting if we could make alkaline medium. Now there is a need to do the steps to prevent rusting. So next topic is prevention of corrosion, or I'll say rusting. One of the step is barrier protection. If you make a barrier on the metal surface so that it may not come in the contact with air and moisture, then you can prevent rusting. So it can be done with the help of painting or oiling or varnishing, or sometimes we also do a coating with non-corrosive, which are not harmful, non-corrosive metals. It could be nickel or chromium or copper. Many times you might have seen in the market some beautiful articles which are very shining, and generally they are coated with non-corrosive metal of nickel and chromium. There are some other methods also, and that is it is called as sacrificial protection. This is also about making a coating of some metal. But what kind of metal? There is a specification in this case. So when a metal with low reduction potential, or I may say a reactive metal coating is done. Children, my video stopped in between, so I'll repeat. Children, generally iron articles are coated with zinc, and you have done this process in the junior classes also, which is named as galvanization. Coating of zinc over iron is called as galvanization. Children, zinc is more reactive than iron if you check in the reactivity series. So zinc, if it is coated over iron, will not allow iron to be exposed to air and moisture, and iron will not undergo rusting. Suppose there is a scratch on the surface of iron or over the zinc. You will see now both of them are exposed to air and moisture. In that case also, zinc will sacrifice on account of iron because it is more reactive. More reactive metal will undergo oxidation. It will act as anode. So I would like to say, as you have seen in the mechanism, in place of iron, zinc will undergo oxidation. It will change to Zn2 plus, and further reaction will happen with zinc only, and zinc will make rust, or it will undergo corrosion, and it will protect iron from rusting. So more reactive metals are coated in order to prevent it from rusting. When I say more reactive, so in terms of reduction potential, you can say more reactive metals have low reduction potentials. So in the electrochemical series, all those metals which are placed below iron will be able to protect iron from rusting. So remember, the metal which has to be coated should have low reduction potentials. Metal with low reduction potential will act as anode and are more reactive, and such metals are able to protect iron from rusting even if there is a scratch. There was a question in the board. They said there are two iron articles. One is coated with zinc, other is coated with tin. And in both the cases, if there is a scratch over the surface, in which case rusting will take place over iron. In this case, I have explained that no rusting will take place in this case, even if there is a scratch. What happens in the case of tin when iron is coated with tin? If you check in the reactivity series, you will find that iron is more reactive. So tin is less reactive. As tin is less reactive, it is able to protect iron as long as this is over the surface of iron, because iron will not come in the contact of the air and moisture. But when there is a scratch over the surface and both of them are exposed, then out of two, one which is more reactive, in this case it is iron, will undergo oxidation, will act as anode. In that case, tin will not undergo oxidation. And in the electrochemical series also you can check, reduction potential of tin is greater than iron. And I have told you, all those metals which have low reduction potential will be able to protect that particular metal which has been coated. So why do we call it as sacrificial protection? Because in this case, zinc is sacrificing on account of iron. Zinc is undergoing corrosion. Zinc is undergoing oxidation. It doesn't allow iron to undergo rusting. So it is sacrificing on account of iron. These two are good friends. So zinc doesn't allow iron to undergo oxidation. There are certain other methods also, that is electrical protection. You know, when there are long pipelines are there, or some iron tank which is very huge is there, in order to prevent it, in order to protect it from rusting, oiling, painting, varnishing and other methods are not very feasible. In that case, if you connect it with some reactive metal, you take a piece of magnesium maybe and connect it with a wire through this magnesium metal, you will see in that case magnesium will undergo oxidation. This will act as anode. It will not allow iron to undergo oxidation. So magnesium is there, aluminium is there. If such small pieces or metals are connected with this maybe pipe, or you can say tank, then it also protects iron and it itself undergoes, and magnesium and aluminium themselves undergo oxidation, undergoes rusting. We can also use anti-rust solution. So one more method is there, that is anti-rust solutions. So if the object or the substance is coated with alkaline solution of some phosphates or chromates, then also it is able to protect the object from the rusting. So as I have mentioned here, alkaline solution, when alkaline solution is there, so acidity decreases, hydrogen ion won't be able to produce, this mechanism may not happen and rusting will be prevented. Children, you might have seen in some paints Nowadays zinc, magnesium or aluminium, which are very reactive metal, their powder is added in the paints and varnishes, so that also prevents it from rusting. Children, this is the end of the chapter. So let me revise what we have done today. One is the definition of rusting. Other is the mechanism of rusting. Why rusting is added in electrochemistry? Because it is based on the principle of setting up of electrochemical cell. Iron acts as anode and impurities act as cathode. There are some sources of hydrogen also, and rusting takes place. Then it is very interesting to note that if iron is kept in the vacuum, no rusting will take place. Even in basic medium, rusting doesn't happen. So there are certain methods to prevent rusting: barrier protection, sacrificial protection, electrical protection, and by the use of alkaline solutions of phosphates and chromates. Thank you.